will teach you. So then you can start working on, of course, in the theory. 5 p.m. same time, same time is same. So maybe 1 hour takes 1 hour, maybe less. So if you have your laptop, computer, MATLAB on your laptop, it's okay. If not, no problem. We have it in all computers in the lab. So I think better to use your laptop because maybe you don't need to come to college for doing MATLAB. For your laptop, you can. So we'll teach you how to install also if you want to have MATLAB in your computer laptop. We teach you how to install MATLAB also, but not necessary MATLAB for your computer. We have MATLAB in the lab. Okay. So tomorrow, next week will be only on campus. Only on campus because online sessions for doing simulation is not interesting, not useful. I recommend you strongly come to the college here to be in person. Okay, so very easy today. We have a short session, just explain exactly what is the requirements for the assignment. So let me share with you the screen. And explain it. Okay, this is MATLAB assignment for control. I uploaded already. This is available in Moodle, so you can go to Moodle and download it. If you don't have access, you can email me and I will send you by email. So this draft is the assignment. The deadline is end of May. The 1st of May. I think it will be after holidays of Eid. Okay. So this is individual. Yeah, this is available Moodle and submission also in Moodle, not by email. But before submission, 1 week before, you can email me if you want for my feedback to see if you do okay and everything in on track. Yes, this is same for you all, one for all, not different things. So all things are same for all. So I will explain how to do it step by step. So for marking, 50% of your final mark is for final exam, 50% for the assignment. So for assignment out of 100, calculations, those problem solving task 1 and 2, I will explain, is 50%. So be careful about calculation, the numbers. If you want to make sure that if your calculation is correct, you should look at the result in the end by MATLAB. So if the MATLAB output is okay and well working, then it means calculation is correct. Here, calculation is not like final exam with just one solution. Maybe you have different solution. I will explain it now. So don't try to be same all things, but the step by step should be same. So the equations all is same, but maybe you choose some different numbers. It's about design. Design has flexibility. Some parameter you can choose differently with your friends. So it's very flexible. For example, you will find Kp equal 100, another student 250. It's okay. There is no right and wrong. Just finally look at the result. If the result is okay, very well, works well, not oscillating, not attenuation, not very overshoot highly or overdamp. So in that case, it means that the calculation is wrong. So 50% for calculation. When we say calculation, it means equations also. There are some equations you should derive. System modeling. If you remember, I talked about equations, how to find the relationship between output and input, how to find transfer function for each block, how to simplify this. So you should apply all of those calculations here in assignment. You can write by hand or type, it's up to you. When you by hand, then scan and high quality so that I can read it easily. Okay. Discussion of results 15%. In the end, of course, we have a conclusion, but after calculation and showing some results, you should discuss the result. Discussion is very important. Many students, I saw that very simple and brief discussion. Uh, it has 15%, but I expect you to have a detailed discussion. For example, not just one figure, not output one. You should discuss, which means that if you change the parameters kp or ki, it's up to you. You change these parameters for the PID controller. What's happened to the output? You should show me at least two. The more the better, plots, and compare them and talk about the effect of these parameters on the output. For example, you say, if I increase Kp, I see in figure 2 that overshoot comes down. For example, this is exactly what I want. If Ki changed to, for example, twice, let's say twice, then you see that the oscillations keeps faster, for example. Such a discussion in technical language. Not saying that if we increase this, the result will be better. Okay, so this is very brief and simple, basic. So 15% for this calculation, and we have another 15% that is for introduction and conclusions. This should be brief, no matter. Introduction, just one paragraph is enough. No need long, no need literature survey, no need this, no need. Just introduce this project. Say, in this project, we want to design a PID controller for a motor, DC motor with these parameters, and we are going to have for example, under control system with these parameters, and we check that the error is very low and this kind of things. So one paragraph for each of these sections is enough. And then presentation, well-written presentation, explain, after finishing this part, have a bridge to the next part. So say next part, we will discuss the result. So well-written, not just calculate and then gap between the sections, okay? And also a reference, yes, you can use some reference, some books, chapters, or some papers, tutorials online, put in the reference part in the end. Maybe one or two is enough, no need long, maybe 1-2 reference. And programs, no need that MATLAB, because we don't have MATLAB codes, we have some Simulink model. So that Simulink model, next week we will show you how to do it. That's enough. Just a screenshot of that and paste on the report. And also the plot. The plot is a part of results and discussion. But when you say programs, just a screenshot to show that you use MATLAB. Okay, we will show how to screenshot and copy and paste from MATLAB to the Word. Because final report should be in Word or PDF format. So we will instruct you how to do it next week. Okay, so that is 10% means you did MATLAB of the total. So yes, that is for marking scheme. For system explanation, yes, we have a motor, a DC motor with mechanical load. We have a load, rotatory load, like fan. You wanna control the speed of this fan, and we want to do the controller by RLC circuits, and RLC circuits represents the PID controller. The PID controller is composed of RLC. So the goal is to find the Kp, Ki, and Kd, which is not represented here. It is something that you should add to this system. You don't need to draw anything, you just need calculation. So how to find Kp, Ki, and Kd? First step I will explain now is to find the system modeling. What is the relationship between output to the input of system? Let's have the block diagram. This is mechanical system, electromechanical systems, all the systems. But when you bring it in paper, it will be a system model, block diagrams. For example, G of S is the system. For example, you give it voltage and it gives you rotation. Omega is rotation, rotational speed. So when it rotates, it generates omega. So you give you voltage to the motor and it gives you back the omega. And that omega rotates velocity gives you theta. The theta means the angle of that fan. So you want to, for example, fix exactly at that point, and that fan, for example, or anything that, or wheel, anything that rotates. So in the specific theta, okay, so you should control it. So before that theta, we have omega, that is velocity. And before that, we have voltage. So what is the relation between omega s and Vs? That is transfer function, internal transfer function. The first step is to find omega s over Vs. I don't want to solve it. I want to explain what to do exactly. Okay, so this is your job to think about it. And of course, as I have it here, the equation and hints on equations, this is, I explain it in the end, how to work on with this. So let me explain the question first and then go to the guidance part. Yes, this system, we have I current, L in inductance, R resistance, and tau, or T, capital T, is torque, and J is some constant, omega is the velocity, rotational velocity, and there are some equations for this. I will list, we had it before in a slide, but I bring them all here in this. So I will upload this explain coursework draft in Moodle. I will explain after class, I will upload it. Okay, so you can use this hint. So these are the numbers, you use it. J, constant number for rotor, friction constant for motor again, which is about viscosity, mechanical property. B, numbers. Ke is electromotive force constant, that is for motor. And then we have another motor constant number, which torque force. Force is torque. If you push something directly, it is force. If you push in these directions and rotation, it will be called torque. Okay, torque is same as force. Okay, so since it is rotationary, we say torque. Okay, so the number for this is Kt, and R 1 ohm for the electric resistance. Okay, so here I explain how they are connected, and then transfer function. So I give you this. This is part of the questions to make it easy. Part of this is given to you. Don't need to start from scratch. So you can start from here. So GS, you see, the first step is to find GS. What is the relationship between omega and the V? So there are some equations. I give you this equation here. So these are the list of all equations. So V, VR, VL. Do you remember system modeling for RLC circuit the first week? RLC and KVL, KCL. This is similar to that, but a little complicated because we have some mechanical equation involved also. So here in the end, you see V, VE, VR, VL. VE is this one, VR is this, VL is this. So then the summation of these, V equal summation of these. The goal is omega, the first step, not the goal. The first step is to find G of S. So you see inside, you see G of S. Just one moment to go to online. Students, maybe they have some questions, I forgot them. It's a moment. So. Okay. Everything is fine online, students?
Mister?
Yes.
Share your screen.
I share screen, stop present. Maybe the other students, they see or they don't.
Yeah,
Yes,
yeah,
we
we
can
see.
see, Mr.
It's
We see
okay?
it. Yes.
Yes.
Oh, yes, it's okay. You can disconnect and connect again, or you can open that from Moodle. In Moodle, there is that file also. Okay, if you go to Moodle, you can download that draft and open that. It's same draft. Okay. So first step is g of s. This g of s, you should find the relationship between omega and v. How to find? Using this equation. See, v omega, these are equations. I, you see here we have I, here we have I. Forget about t because t we don't use t. Okay, we don't use t. Yes, so kti equal this omega. Okay, so I is here also. So of course you need to um, write all in Laplace domain. Okay, Laplace domain. So for example, here and here, Laplace domain, VL equal L SIS. You remember when we convert from time to Laplace, we replace di with s. Okay, so all of them here in time domain, but you need to convert to Laplace domain. Okay, all of this equation. So all of them will be converted to Laplace, and then you will find omega over v. This is first step. Then you will find theta over vs by using this. It's very easy, theta to v, because here you see theta and omega. Theta over omega is 1 over s. So you have omega over v also already. So then you can find theta over v. Okay, so this is the first step. And then finding this transfer function, multiply with this one, it will be another transfer function. So yes, here, let me show you. Here. So first we will find this in this rectangular dashed line. Then we will find transfer function for this part. Okay. We have formula G over 1 plus GS. This all G, this is H. So you will find the transfer function for this. Then we will multiply with this because they are cascaded. Okay, so this all will be another G, a new G. And finally, you will find that output theta, this theta output to the desired theta, theta D. That is the overall transfer function. That's all you need for this 50 mark. All things that until now, that is calculation, including formula derivation and calculation, mathematical, numerical calculation. So 50 marks. So if you don't do MATLAB or the rest of the work, discussion, just do this MATLAB part, only calculation part, you get 50. Okay, so that's why most of the students do it 50%, at least 50 they get. Of course, introduction, you can do that also. So then, yeah, how to start here from this equation. Okay, so then you will find transfer function, and this transfer function should be implemented in MATLAB. Next, we will teach you how to implement a transfer function in MATLAB to get the output, because you cannot draw the curve by hand. Calculation and measurements by hand drawing. You should use a computer program like MATLAB. So next week we'll teach you how to do it, MATLAB connection, block by block, line between two blocks, modules. So we'll teach you next week. Very easy. So then you run the program and get the output result, some curve. Okay, that is your result of PID controller. So now, yes, of course, this transfer function is the main part, the core, the major part of your assignment. Because without this transfer function, you cannot do anything. Okay, so in that transfer function, there are some parameters like Kp, Ki, Kd. You see here, if you look at this figure, you see Kp, Kd, Ki. You see, these are the parameters you should find. When I say design the controller, it means that you should find these three parameters. That is again part of the calculation. It's not separate. So Kp, Kd, Ki. So Kp, Kd, Ki, if you remember last week I talked about it, but very simple second order system, first order system. Last time I talked about it and I solved a problem solving with PID for second order. Just Kp or Kd, one of them, not all. But if you have three, then it is like third order system. So we don't have formula for third order system. You know, we have S2 plus 2 zeta omega ns plus omega n squared. We have two parameters only, zeta and omega n, and second order, not third order. For the case of third order, we have an approximation solution. I will explain it here with an example. Okay, so this example show you how to approximate third order with the second order. By the way, if your system modeling equation becomes second order, it means that you make mistakes somewhere. So make sure that the result should be third order system transfer function. You know, that TF should be like that. This something like that. You should get some number, some transfer function like that. This is very simple. Maybe just example. Not this is not answer. This is just example. So your transfer function system modeling should be a third order like that. So now the question: how to find the Kp, Ki, and Kd? That is the last step of your design. So here the trick is we add a large pole minus p, like 100, 200, or any large number. P can be a very large number. Here, the way the place that I said, it is optional. You can have different results. So, for example, select 100, another one 200. So different P gives you different numbers, different PI, Kp, Ki. This is okay, but the result may be a little change. So that's why it's very flexible. You can choose, for example, P100, P. So then you will have equation like that. You see the equation. TF is omega n square, S plus P, S2 plus 2 zeta omega n plus omega n square. So this is, I multiply that pole. Pole is the root of the denomination. So the denominator is third order. Since the classical standard one is second order, we add another pole to becomes third order. Okay. So then, if you multiply this first order and second order, it becomes third order. Okay, see, third order. This third order will be equal to this one that you found before. Okay, so now here, P is something that you choose, optional, for example, 100. Zeta and omega n. What is zeta? I didn't give you zeta and omega n, but I gave you some other numbers here. Let's see, some numbers I gave you. Yes, rise time, overshoot map MP less than 5%, settling time, and error 0 for a step. So I didn't give you zeta and omega n, but I gave you this one, these numbers. So you have to find zeta and omega n. Okay. So before any calculation, before Kp, Ki, Kd, you should find zeta and omega n. How? Slide number 7. In slide number 7, you see Tr equals this. All of these time, settling times, peak time, and overshoot, all of these are given here. Equation are all given here. Settling time, all. So from this equation, you should find zeta and omega n. So you need zeta and omega n. By using this equation, slide week 7, you can find it in Google. Of course, Google, you can search Google also. All of these equations are in Google. You can find all of them. Or you can go to Moodle and find week number 7 slide. Okay, so these are given. So before Kp and Ki, find zeta and omega n using those equations and having these numbers. Okay, so then everything is ready. Here 20 plus Kd should be equals P plus 2 zeta omega n. You already found zeta omega n, then we'll find K. Finish. Kp, 2 plus Kp should be equal to P zeta omega n plus omega n squared. And then Ki should be equal P omega n squared. Then all of these three parameters are obtained and done, finish. So which means that you obtain the parameters for the controller, and of course you found Tf, and then putting those Kp, Ki numbers inside Tf, and then use MATLAB to find the output, results for output. So next week we'll explain it in class how to design, how to find the results for transfer function by your Kp, Ki, and K. So step by step. First, transfer function. Okay, transfer function using these equations. There are two steps here: internal transfer function of Gs. So here Gs. This Gs is obtained by this equation. So these equations are all for Gs. Okay, Gs. After Gs, you will find theta s over Vs and then theta s over theta d. That is block simplification here. This way, and finding this, you will find a transfer function like this. Yes, this is the result. You should have such a equation, fraction. So after this, you need to go to on this slide to find zeta and omega n, because here you select p equal 200, you put something like 500, 1000, any numbers is okay for p, and then zeta and omega n you find by using those equations, and then one by one equivalence. 20 plus Kd equal this, 2 plus Kp equal this, Ki equal this, you will find these three variables. So that is 50% of your calculation. So you see, the bottleneck is we have in class only second order system, but here in the assignment we have third order system. So you need to learn this approximation. So I will upload this one for your record in Moodle. You can use it later. So then, so this is the parameters, control design, and plot. And there is another part, 15 mark, that is part of, depends. Sometimes I consider it as a discussion part. Sometimes for example, if you did discussion part very well, okay, so then I put the mark for that one full for you, and I consider this for your calculation. But if your calculation is very wrong, bad, then I will change the marking scheme. So I want to give you good mark, Okay, so that's why I add this part to the assignment for your help. Okay, to have extra mark. So 15 mark, that is a research work. There is no any calculation, any derivation. Just search online about a tuning method. So Google, type this PID tuning method. So that is for your information and my information. So this is one example, Ziegler-Nicholas. Is just one method. There is another method, more methods. So just pick up one of them and learn it, and then just half a page is enough. Explain in the end of your report. Okay, so this is separate from calculation. Those numbers. This is general method. Uh, But for marking, I can consider for your calculation that part of that 50%, or I can consider for the discussion. Depends on what your quality, how is your quality of your writing. Okay, so that this is like extra 15 marks on that. So this part is a research part, just research part, not MATLAB, not formula. No need to, use any formula equation. Just explanation. So, for example, in Ziegler method, first we look at P. If the P is very high, then we reduce it, and then if the result is okay, then we comes down PI. Look at PI, and then PD. So you should search and see that information about these tuning rules. Okay, that is for assignment, how to do it. But MATLAB part is another part for plot, for output result. So next week, we will cover that part. Okay. So from my side, is done. I hope that everything is clear. But if you have any question, something not clear, please let me know.
Yes, Mr.
Yes.
All questions same for all students, huh? Questions or different number or same?
Oh, sorry, again.
Yes, dear, clear my question.
Screen is not working for you?
No, working. It is working. But I have one
Okay.
question.
Uh-huh.
My question said all questions it's same for students or different
Yes.
numbers.
Numbers, everything same for all. Yes.
Okay, thank you.
Yes. Yes.
And
Yeah. If
the
you have
deadline
any question,
the
you
deadline will be the end of the May, yeah?
yes, end of May. Yes, next month. Yes. During your assignment work and working on, if you have any question, you can come to me and office, and I will explain if something is not clear, some problems maybe. You can come and I explain more. Okay. مرحبا. All right. Uh, yes, I will upload this assignment explained in Moodle. So to have this last page I added. So this one is, this page, very helpful. Please use it. And then if still some problems, just come to me and or email me. I will explain more.
Okay, Mr. Thank you.
Okay. Thank you. Just one moment for screenshot for your attendance. All right. Okay. So So next week we will have MATLAB lab session in campus. So we will have recording if you cannot attend, but better to attend because it's very important. And then after this, we will back to the theory. Okay. Any other question or concern?
Mr.
Yes.
That MATLAB for next week, inshallah, that will be related to our coursework, helpful for our coursework, means, or something related to our final exam.
It's only for assignment, not final exam.
Means that to clarify how to solving that as our assignment.
Let's see that. Let me disconnect here. Sorry, I didn't get you. Can you?
I mean that next week class, there will be that helpful for our assignment or for final exam?
Only for assignment.
For assignment, clarifier means.
Yes.
Okay.
Only final. There is no MATLAB requirement for final.
But there will be for the final.
Final is theory, like system modeling, something that I explain it now. For MATLAB, for final, we have revision sessions, 2 weeks. We have revision, and I will explain and solve all of the questions that come to your final exam. So all of them will be covered in 2 weeks before final exam.
Okay, Mr. Thank you.
Welcome. All right. Thank you for your attendance, and see you next week, inshallah. And goodbye.